wanted to give you a quick overview of this new project called Tokesim. And what Tokesim is an agent-based modeling token economics simulator. So what can you do with it? So the aim is to be able to evaluate the behavioral economics of a token economy that you're creating. So what Tokesim allows you to do is to test out the economics of your smart contracts. It's built to be more blockchain agnostic, but at the moment, it's just using and supporting Ethereum. But it is built in an extensible way. So let's dive into it. There are three different repos. So there's Tokesim, the actual simulator, Tokesim chain, and Mesa Behaviors. And we'll jump into that in a second. So let's just start Tokesim. So this is a Python 3 project. So actually, I'm going to create a new directory called Tokesim demos. And then let's go ahead and create a virtual environment. This will be nice. And just for reference, Tokesim is a Python 3.7 compatible program. And the reason for that is that there are some sub-dependencies that are only supporting 3.7, so you can't support 3.8. But there's nothing inherently that prevents us from bumping eventually to 3.8. So pip install Tokesim. Okay. Wait for it. Okay, so now Tokesim is installed. Let's see what we have. We have Tokesim, Tokesim. Okay, so we're just going to run Tokesim, and the help message just lets us know what's there. And so the first thing that we need to do is create a simulation. So let's see what this does. Okay, I'm missing arguments. Let's specify the directory we want. So toke init or tokesim init, depending on which command you want, will allow you to specify a directory that you want to generate the simulation code for. So here's what I'm going to say. Test simulation. And here I'm going to just specify the number of agents I want. It doesn't have to be generated this way, but what it does is generate a bunch of accounts and addresses that you can then pull from as like a pool of addresses and public and private keys for when you're running the simulation. So I'm just going to choose 10 agents so that way it's small. We created a simulation. So now let's see what's on the inside of this directory. We'll go test simulation. Okay, so we have the accounts, config, contracts, our agent. We have the simple token config, which just sets up some of the model parameters, and then we have a dashboard and the token model itself. So I am just going to run it and see what happens. So I think the command was, if I recall, Let's go run. Oh, okay, so we're missing config. Let's go ahead and specify what the config is. Just test simulation, simulation.json, and then we're going to give it a port. So I'm going to pause right here, and I'm going to open up a new terminal, and I am going to install the simulation chain service. I know it's a mouthful. So what it does, npm install sg at tokesim /tokesim chain. So what it does is it provides a service, an RPC service, that allows you to control the test environment chain state. So you can control when the blocks start and when the blocks end. And this helps you keep your simulation in sync with the actual blockchain. You don't actually have to do that, but it is useful in just like coordinating your results. So some transactions don't get left behind in that block and just makes things easier. So we'll do Tokesim chain. Let's see what we have. Okay, so specify the chain and the port. By default, it defaults to an Ethereum chain, so that means Ethereum Classic or Ethereum. So Tokesim chain, specify the port. I'm just going to say let's run on 3004 because I think that's what I say. I think? Okay. So now we have this Tokesim chain service that's running, and it's running like an Ethereum chain. Underneath the hood, it's using Ganache. And so now let's go back here. And so this port will be corresponding to the simulator port. So in this case, it's 3004. Let's see what we get. Oh, okay. So what we have is a token dashboard. And this dashboard is testing a token that I launched called Simple Token. And what it does is it mints tokens on a linear price point. And that price point is 10,000 times the token supply. And internally, the model that we're simulating is called a minority majority game, or a mixed minority majority game, where the agents are following a pattern and they're saying like their utility functions are such that 40% follow the majority and 60% follow the minority. So if a lot of people seem to all buy tokens and you're in the majority pool, then you optimize for predicting when that's going to happen. And if you're in the minority pool, you're optimizing for predicting when you're going against the grain. So they've used these functions to model pricing changes and like the NASDAQ stock market. So it's not uncommon to use this kind of simulation. So let's just start it and see what happens. Okay, so what we see here is this initial peak here, and then we see some dips, and we see that it's going straight rise. And that's because the agents at the moment have infinite budget. But these dips are actually representative of the contrarian positions from people buying and selling. So in this case, both are pretty well balanced. And so what that means is like you get more or less this linear, not so volatile price change. So what we're going to do is just change the model up. So we're going to stop that. And I'm just going to, exit out of this. And let's step into the code. Okay, so we have our virtual environment, we have test simulation, and actually, I'm going to change this to this. Now you can actually see the screen. Um, so here's basically what happens. So here's our agent. It's called Simple Token Agent. Um, ignore this, ignore this. Let me just set up a virtual environment. Python. Select interpreter. Yeah, this seems right. Cool. So now that we have this all installed, we'll go forward. And so basically at every step, the agent is going to take an action. And so what it's going to do is look at its utility score, which are a set of strategies, which in this case, it's a little bit more involved to go into the details, but it's a set of binary encoded strategies that look at the past in states of memory to try and figure out what action they should take, and then how well those actions performed dictate what the new what the next action should be. Okay, so that's kind of a mouthful, but if you dive into the utility score, it'll make a lot more sense. So here we have the agent features, which are like what they did with the tokens, more or less, and then the actions, which are encoded in terms of what they did. So action, that's -1 is a sell, 0 is a hold, and 1 is a buy. Okay, so what we want to do is change the way that the model's distribution is. So we're going into the config, which is basically specifying how the model is configured. What this does is allow you to either do a configuration in code or to do a configuration through the actual config file. So if you look here, we have this model, which has the class name, the module name, and the module path. And then we have a bunch of params that don't require any code that you can pass into the model. So here I'm saying the token name is going to be my token symbol. I'm talking about the number of agents, the memory that we talked about earlier in the strategies, how retrospective those agents are, and then like the number of strategies that they can choose from. So they randomly generate like 4 or 5 strategies, but you can generate more just depending on like the size of the memory and the amount of space that you want the agent to cover. So let's get back to just changing things around and then seeing what the results are. So here I'm going to say that I want 90% of the agents. So here are the agents and the agent labels, in which this case it is in sort order. So it's minority, majority, reverse sort order rather. And the label I want to apply 90% to is this minority, and then the label I want to apply the majority to is 10%. So random choices will give me this kind of sampling with this weight. So it is a stochastic process, so this will just happen. It'll be cool. So now what we want to do, we'll go back to our terminal. We will just simply run it. Okay, so we already started a simulation and we have plenty of like ETH there, and we also have this accounts file. So I'll just pop into that really quick, and this accounts file is basically being mapped to the different agents. So they have a balance and a budget and public and private keys. So you can recreate the accounts assignment to various agents. So it kind of gives you this ability to, if you wanted, convert these accounts.json to a Genesis file and run this live against a proof of authority network, or even actually against some other networks, given that you have balances for any of these accounts. Okay, so we're going to just pop in the terminal. Okay, and run test simulation. Fig test simulation. Simulation.json. And was there anything else? I don't think so. Yep, port. And in this case, our simulator is running on 3004. So let's see what happens. We've changed things radically. And if you look, the volatility is starting to get pretty insane. And that's because you have so many people that are trying to be contrarian that it's causing a lot of the price to move in the exact polar opposite direction that it moved before. So it's not crazy to suspect with a linear token function like this, an infinite budget, that you'd see this much price volatility. Okay, so that was my demo, and this is like sort of a phase 1 of Tokesim, and this was pretty much so how you run the program and how you sort of tinker with a simulation. And really the project is composed of 3 components. One is the Tokesim chain server and client, so that's the thing that we started earlier, that runs the simulator with an RPC interface that you can then hit. And that interface looks a little like this. I'm going to try and do this live. So we have a little playground, which is a cool project that we use this technology called OpenRPC. And if we go here, boom. So this tells us like what the interface is. We can try these results out to start and stop a simulation, to end blocks, etc. Okay. And the other side of this, and one that will probably make a little bit more sense if you're digging around into the code to figure out how things work, or how you write an extensible agent or utility function, is this project called Mesa Behaviors. And so it's an extension on Mesa. There aren't really any docs on it yet, but those are coming. And what it will do is describe how you should describe agents, which is just basically, it's an agent, it has generics that takes a strategy, a history, and a feature set. And this level of abstraction allows you to decouple the agents from the models that they're running in. And basically, it will allow you to drop one agent into an entirely different model. So if you had an agent that replicated the budget of a particular city or a particular demographic, and you've done a lot of work there, and you want to, say, put that into simple token, this provides the interface to make that happen in a way that is understandable to you and someone else. And so for simple token's sake, you would just provide a binary history function and a binary utility function, and then you'd be off to the races. And so it talks about, like, what is this utility function? What's a utility score? What does history look like? Etc. And if you wanted to get up to speed a little bit faster, you could go through the tests. You go to models, and you go to test models. It really kind of shows all the steps that you would need in order to write a model and retrieve data and generate populations, and to do this in an extensible and repeatable way. So thank you, and I can't wait to see some simulations and start building a collection of behaviors and utilities that are shareable for testing token economics. Thank you.